Okay, so if we look at this data now that we have, so I ask you to draw this, and there's our quartile 2 sitting at 8. There's our lower quartile on 4, our upper quartile on 10, and then my minimum is 3, and my maximum is 15. So now from here, we want to construct a box and whisker diagram. And notice, I think when you're drawing, don't start at 3. Go up till just 1 below 3, so you can see where the whisker is ending. So let your scale start at 2 and just go 1 above 15. Let's go to 16. All right. So it's very clear. So when you draw a box, your box needs to be drawn from 4 till 10. And then your median is going to sit at 8. And then from there, we're going to get our whiskers coming out. So the whisker is going to your minimum 3, and it's going to a maximum 15. And there's our box and whisker diagram. Please note that in an exam, they'll tell you give the 5-point number summary. So you must be able to say minimum 3, Q1, Q2, Q3, and the maximum. That's called a 5-point number summary. Now we talk about the skewness of the box. So to understand the skewness of a box, or the data, I should say, we look at where the median is. And if you look at your box, the box is bigger on the left. So if it's bigger on the left, then we say that this is negatively skewed. If the median is in the center, then that we call normal distribution. So 3 keywords I'm teaching you now. If the box was bigger on the right, then we say it's positively skewed, because when we go to the right, we're talking positive numbers. When we go to the left, negative. So does that make sense in terms of skewness of the box? Yes or no?
Yes, sir.
No, sir.
Yes, sir.
Okay, so 3 words you need to remember. This box is negatively skewed. You get a normal distribution. That means this median is in the center. And then you get a positively skewed box where the right, if we're looking only at the box now, if our blue line was around 5, then we can say it's positively skewed. So can you see there's more data on the left in terms of running from 4 to 8 compared to running from 8 to 10.
Sorry, so
Yes.
So does it
Listening
have
to
to
you.
do with like the medium inside the box?
Sorry?
Does the skewing only have to do with the median inside the box, like nothing to do with the whiskers?
So the worst case telling us 25% of the data is between 10 to 15. 25% of the data is between 3 and 4. Remember earlier I said quartile 1 represents 25% of the data. Quartile 2 represents 50%. Quartile 3 represents 75%. But we can read it the other way now. If we're going from right to left, that's 25, 50, 75. We're not going to go too deep into this. We go more deeper in grade 11. So for grade 10, that's all you need to know. Okay, that's another example. We're going to skip that. So let's look at 2 given boxes. All right. Here's a question where they give you the whisker diagrams. So Gemma recorded the heights in centimeters of girls in the same class and constructed a box plot from the data. Is everyone with me? Okay. And it says the box plots for both boys and girls are shown below, as you can see. Use the box plots to choose some correct statements comparing the heights. So this is about heights of boys and girls. If you look at the data right now, what is the first thing that, if the data is representing heights of boys and girls, what's the first thing that comes to your mind?
So that the boys are generally taller than the girls.
Very good. If we just look at the data at face value, we can see the boys seem to be taller than the girls. So now let's go and look at if we can answer these questions. So the first question is, number one, the girls are taller on average. Would you agree with that?
No, sir, because the median of the boys is higher than the median of the girls.
Sorry. Very true. The boys are taller on average. Would you agree with that?
Yes, sir.
The girls are showing less in terms of variance in height. The smallest person is a girl. Is that true? Is the smallest person a girl?
Yes, sir.
The boys show less variance in height. And the last one is the tallest person is a boy. Is that true?
Yes, sir.
So now let's come back to number one, which we said no to. The question in number one says the girls are taller on average. Now remember, the box is not showing us in terms of your averages. How would we find the average? If we look at the
mean, sir.
data, somebody.
So the mean is the average, sir.
The mean is the average. All right. Remember, these are all averages. Median, mean, they all called averages. All right. Just that from the lower forms, we always spoke about average very loosely. Okay. So now, if we actually be very specific, the mean is what you knew back in the days as an average. So we now need to use, we don't want to use these words very cheaply anymore. So we must talk about the right words moving forward. We talk about a mean and we talk about a median. All right. And if we just look at the data, we'll be correct by saying if we add all the data, you can see the tallest person is a boy. The boys start off with bigger heights, all right? So we can justify that. Okay, this is called an Ogive curve. Have you heard of an Ogive curve?
No, sir.
All right. No, very good, because this is for grade 11. So don't worry about the Ogive curve. Okay, so I'm going to stop that one. And then we're going to go to the next thing I want to discuss with you is group data. Have you heard of group data?
Yes, sir.
All right. So now we're going to go on to group data. So I think the first one was quite simple. So we call this group data. Group data basically means we get collecting data in terms of a range. If you look at what I have on the screen, the number of laps, so, and the frequency. Frequency is how many people did laps between 1 and 5. So we are saying 2 people did laps between 1 and 5. 9 people did laps between 6 and 10. So frequency is basically a count of how many in each range. So group data, 1 to 5 is a range, 6 to 10, 11 to 15. So this is our group data. Now, we talk about the word mode. Have you heard of the word mode? The word mode
Yes, sir.
Mode means the most common, most popular. Simple terms, if we're looking at a table like this, we can't talk about a mode. So we talk about a modal class. If we look into this, which will be our modal class?
26 to 30.
Sorry, what is that?
26 to 30, sir.
26 to 30. Don't tell me 25, all right? That's a frequency. I want to know the modal class. The modal class is 26 to 30. Now, if I had to ask you to go and find the range, sorry, not the range. If I could ask you to find the median or the mean, how would we find the mean?
So you'd go
Okay.
to the middle, so you'd go add them all up and go to the middle number. So the average is somewhere there. So
Okay, so we can't find the average directly. So in other words, what we're going to do is find the average of the average. That's quite tricky what I just said, okay? Before I go on, the group data is grouped into 8 class intervals of which 4, right? Data is discrete. Okay, we'll come back to that. Now, if I want to find, the question here is to find the mean number of laps. And in the old days, you would call mean and average. Now, the problem, we don't have the exact data. Because if you look at 26 to 30, the number of laps running to 26 to 30, we have 25 people who ran between 26 to 30, but we don't know that how many each one actually ran. Okay, let's go to a smaller number. If we go to 31 to 35, there are 2 people that ran between 31 to 35. We don't know these 2 people, did they run 32 or did they run 33 or did they run 34? So we don't have the exact data. So, because normally what we'll do, we'll add all and divide by the number of numbers. Now we don't have that, okay? So to estimate the mean, that's why they're using the word estimate, all right? You're going to estimate. You will have to, and you see my table now changed. You have to find the midpoint of the range. Now the midpoint of 1 and 5, what will the midpoint of 1 and 5 be? Midpoint
3,
is
sir.
the halfway point.
3, sir.
2.5, sir.
So you'll take 1 plus 5, you'll add the end value and the high value, the top value. 1 plus 5 is 6 divided by 2 is 3. So we got 3 there. So we're averaging the class actually, that's what we're doing. The average of 1 to 5 is actually 3. And then we have 2 people running in between, then we will multiply. So this is the midpoint times the frequency. So what is 3 times 2? 6. Okay, let's go find the midpoint. I'm going down first. Midpoint of 6 to 10 is 8. 10 plus 6 is 16 divided by 2 is 8. 15 plus 11. So I'm going to give you some time, quickly finish off your midpoints. Then I'm getting 13, I'm getting 18, 23, 28, 33, 38. Did everyone get that? And then we're
Yes,
going to
sir.
multiply. What is 2 times 3? 6.
6, sir.
9 by 8. Quick maths. Let's test your maths. 9 8s, 72. Come on, a little faster. 15 by 13. 150 and 45, 195. Hey, very slow mathematicians we got here. 20 times 18, quick maths. 10 times 18 is 180. Double that, you'll get 360.
360.
Yo.
Okay, you got to be able to do quick maths here, right? Learn how to do quick maths. All right, 17 by 23. Haven't learned.
391, sir.
Yo, no.
All right, 25 times 28. 700. 2 by 33, that's quite easy. 66, and we got 38. Now, remember what we're trying to do? We're finding the average, the mean. To find the mean, we normally will take the total sum and divide by the total number of numbers. So we need to total the frequency column. If we total the frequency column, what will we get?
$91, sir.
91. So the sigma, which is a funny sign, this is sigma. This sigma actually means the sum, all right? You don't have to write this funny letter that you see. It's a Greek letter. So the sum of this column is 91. Now we need that because we're going to divide by 91. Then we find the sum of the midpoint times the frequency. So we're going to add all the midpoint times the frequency. What do we get there? I'm getting 1828. Can someone confirm that?
Yes, sir.
Okay, and then to find the actual mean, I must take this total sum and divide it by the total number of people involved, which was 91. And if we do that, I can't see my screen on the bottom. Can someone help me out? Can you see my screen on the bottom?
No, sir.
What can someone read that out to me?
It's 20.1.
20.1. Thank you. So we take 1828 divided by 91, we will get 20.1. And that's how we work with group data. And we can do more examples. I don't think we're going to do more. It's the same principle, all right? So I'm going to end that. Okay. Any questions at this stage? So are we all good with, so those are the simple things on stats. I mean, the simple things you can actually can do yourself. And what are some of the concepts we covered in grade 10? Mean, mode, median, box and whisker. And I think you're quite fine. It's quite an easy section, so I don't want to spend a lot of time on stuff that you already know. Okay, we're going to go into some analytical geometry now. Are we all ready for analytical geometry? Yes or
Yes,
no?
sir.
Okay, so analytical itself is quite a simple section, and somebody asked me, will the formulas be given? Can somebody answer that question?
Yes, sir.
Somebody said yes. Are we all happy with the formulas being? I don't know. Somebody asked me a question. I haven't replied to that question. So to my set, if I'm teaching you, I would have just said learn the formulas. If you're not sure, learn it. Is that a fair answer? Or is that being nasty?
So for the first test, we were given the formula set. So can we assume that we'll be given them again?
Now you want me to give you an answer because then you're going to hold me ransom. That Mr. Maestri said that we will be given the form. So I'm not saying anything. Ask your teacher, all right? Don't ask me that question. And to my class, because you guys are not very strong in maths, you can go learn the formulas. Okay, so I want to do a quick walkthrough to going through. I'm not going to actually go through a past paper, but I want to just give you the important points that you need to know for analytical geometry, all right? So if we are given a line called AB, and we got a point called M, what are some of the things that are going to test you to do in analytical geometry? Firstly, you
So
must be
your
able to find AB.
screen-
Sorry?
Your screen's blank, so
Oh, sorry about that. Thank you for informing me about that. Let me share that with you. Okay, so can you see my screen now?
Yes, sir.
I see someone is struggling to get in. Let me just invite that person in. Okay. Okay, what I want you to do after I finish is to be able to go and work with some past paper questions. So the first thing you need to do is be able to find AB, which is the length, okay? So let's put some points down just to make it a little bit more exciting. If we have -3, 5, remember, I'm just putting random points here, and I've got 6 minus 9. How would we find AB? AB is the length, okay? Distance, magnitude. So remember the words that they could use. Find the length, find the distance, find the magnitude of AB. So what would we use? We use the distance formula. Can someone tell me what's the distance formula? Nobody knows the distance
So
formula.
AB is equal to square root x minus x squared plus y minus y squared.
So it's x2 minus x1 all squared plus y2 minus y1 all squared. Are we all in agreement?
Yes,
Yes,
sir.
sir.
All right. So that's the first one we did there. I just want to change the color of my pen now, right? So the next thing that will come out in next thing that can come out, I'm not saying it's going to come out, but things that you need to know is how to find the gradient. How do we find the gradient of AB?
y2 minus y1 over x2 minus x1. So
Well done. Okay. And then the next thing we're going to find is point. Let's suppose that AM was equal to MB. How would we find point M?
So you'd say open bracket
point
x1 plus x2, sir.
Right.
Over 2, sir.
You find the average, good word, average of the X values, and you find the average of the Y values. Did you know that? Now, the next thing that will come on in what we can test on analytical is find the equation of AB. How would we find the equation of AB?
Using the gradient of AB and then subbing a point to find your C value.
Very good. We're going to use the formula Y equal to MX plus C. So we first need the M, which is your gradient. So very quickly, actually to make it more interesting, let's find the equation of AM. Now, I don't have M. But remember, AM and AB is the same line. So if I find the gradient of AB, which I want to do now because I need to use it in equation. If I find the gradient of AB, I'm going to take, I like to do this, put my X and put my Y so I don't make a mistake. There goes my pen misbehaving now. Okay. So if we actually look at this, what would the gradient of A be? Okay, there's my XY and there's my XY. So we would say the gradient of AB is -8, sorry, -9 minus 5 all over 6 minus -3, which gives you a 6 plus 3. And that gives you a -14 over, my pen is troubling me. Okay, you can see that. So we're getting a -14 over 9. Would you agree with that? Yes or no?
Yes, sir.
Right. Now, to find the equation of AM, the gradient of AB is the same as the gradient of AM. So what we want to do now is basically put that into our equation and say Y is equal to -14 over 9X plus C. Now, our job is to find C. And to find C, we can sub any point on the line. And the point I'm going to substitute is 6 minus 9. So the X value is 6. The Y value is -9. plus C. And then you can take your calculators out. If someone has a calculator there. And we can say minus 9. And when we take the negative on that side, it'll become a plus 14 over 9 times 6. Can I have an answer there for C?
So it's a third, so
Someone said a third. Can someone confirm that?
Yes, sir.
So y will now be equal to, returning back to this line here, we get y is equal to minus 14 over 9x plus 1/3. Okay, so that's your basics on analytical geometry. Then we come to the more important, also a little bit more difficult things that you need to know. Can you still see my page? Or has it disappeared?
no, so it's still there, so
Okay. So some of the things I just want to get onto a new page, actually. Let me just get my eraser out. I think that'll be quicker. Okay, we've got enough space now to write. So we're going to talk about 3 words. First word I want to talk about is collinear. Have you heard of this word called collinear? Help me out. Anyone heard of collinear?
Yes, sir.
So tell me, what is the meaning of collinear?
It means they're in a straight line, sir.
In a straight line. So the first word we're going to talk about, if the question comes up, collinear. Sorry, my pen is playing games with me here. My apologies. All right, that's better. Oh, that's much better. Okay, so what do we do to prove that 3 points are collinear?
You find the gradient.
So we talk about 3 points, A, same 3 points, we're going to take A, B, and C. For these 3 points to be collinear, what you would have to do is step 1, find the gradient of AB, make a note. Then you'll find the gradient of BC or AC, whichever one you want. And if these gradients are equal, if the gradients are equal, then those points are collinear. So that's one way you can test a collinear question. Another way is they tell you that it's collinear. Like they may give you a point and say, all right, you know what, this point here is 3, 5. And this point here, you don't know the X value. And this point here is 7, 9. And let's say make this X 6. So if they tell us that these 3 points are collinear, now we're not proving. And they say go find X. So you'll now find the gradient of AB and you equate it to the gradient of BC. And that's how you would find X. So we can form an equation when they tell us it is collinear. So we go to the next one is parallel lines, and I'm not going to spend a lot of time on parallel lines. So what do we know about parallel lines? Can someone tell me?
Gradient is the same.
So the gradients are equal. Well done. So parallel lines, all you need to know is that they will have equal gradients. So if they say prove these 2 lines are parallel, you go find both the gradients, and if they're equal, then we know the lines are parallel. So the most difficult one that we deal with, and this question can come out in 2 ways. Okay, let me just. All right, the next word I want to talk about is a word which is quite a big word, perpendicular. What do we know about perpendicular lines? Somebody tell me that. Nobody.
The gradients are inverted with the change of sign.
That's quite a tricky one, all right, because it depends how it comes out. So if they say prove that both the lines are perpendicular, if they say, if it's a proof question, all right, what you have to do with the proof question is you find your first gradient. Let's suppose it was 3/5. You find your second gradient. And when you multiply M1 times M2, and you can try it on the calculator, you should be able to get -1. If you get -1, it means that the lines are perpendicular. That's how we prove two lines are perpendicular. That is scenario 1. Scenario 2 is where they tell you they're perpendicular. So if they tell you that the lines are perpendicular, and they give you the first gradient to be, say, -5/3. Actually, I'm taking the same one. Let me take another one. So if they now tell you the gradient for the first line was 2. So your gradient for the second line, because it's perpendicular, you will now flip it with the opposite sign. If I flip 2, I will get 1/2. And you got to change your sign. So if the gradient was, say, -3/7, then the other line's gradient, because they're perpendicular, you'll flip, you get 7/3, and you change your sign. And if you multiply these two, you'll get -1. If you multiply this 2, you will always get -1. So the theory behind perpendicular lines is that the product of the gradients is -1. Any other questions there? And the next thing that I want to do in analytical geometry, which I'm not actually going to do, but I'm going to give you some homework, all right, is how do you find the fourth vertex of a palm? So how do we find the fourth vertex of a palm? Anybody knows?
You can use the midpoint.
Okay, you can go to my YouTube channel. And on my YouTube channel, I have a very popular video. It's hitting around, getting close to 20,000 views. Go to my YouTube channel. I have a video called How to Find the Fourth Vertex of a Parallelogram. And I think someone is right. You can use the midpoint. You can use the midpoint technique, or you could use a vector technique. So you can catch that on my YouTube channel. I'm sure some of you have been to my YouTube channel before. You know how to find it. All right, gentlemen, that's a quick walkthrough through analytical geometry. I'm not going to keep you long. I promise we're going to have a short session today. So we covered most of the stuff that you need to know. And now what you need to do is go to the past papers and go and practice. Okay, I had a shorter session today because you're writing tomorrow. Now, I've done my third revision session today, and I've recorded all this, and I've put up all these videos on my YouTube channel. The quality is not the best because remember, it's a live session. Whenever you do a live session, it's not the best. But did your teachers put up the links to the videos in your Teams group?
Yes, sir.
So you all got the links. Please watch. There's some very, very important things I went through if you haven't watched it, all right? Like I went through some good geometry questions, some trick. If you have some time, please watch it. It will help you for tomorrow's paper. Did Mr. Maestri put up the links for his class? Mr. Pillay, did I put up the links?
Yeah, I think you did. So I don't think you put up the link for the first one though.
3.
Yeah.
Okay, I will check on that. But you guys, if you're not getting it, just remember, go to my YouTube channel directly. I've got a playlist there called Revision Lessons. You'll find all on that. All right, are we good to say bye-bye? Are we all good? Any other questions?
Thank you, sir.
Some of you are asking some questions and I can't tell you too much, to be honest. I can't tell you certain things that the rest of the form doesn't know, so I wouldn't tell you anything. So sometimes I'm silent when you ask questions. Sometimes I may respond. You have an exam scope. Follow the exam scope. Is that fair? Okay. And then we can say, enjoy the rest of your study.
Thanks, sir.
Thanks, Sue.
Thanks, sir.
Thank you, sir.
Thanks, sir.
Thank you, sir.
Thanks.